The message arrived without ceremony. No dramatic warning sirens. No urgent diplomatic pleas. Just a quiet, sterile transmission broadcast across every surviving human frequency. Orbital stations, buried communication arrays, drifting satellites still clinging to failing power reserves. Galactic Preservation Council. Extinction Protocol 77 activated. Species designation. Homo sapiens. Homeworld, Earth. Projected survival window. 94 standard years. Probability of recovery. 0.0003%. The galaxy had seen countless extinction notices before. Civilizations rose, burned brightly, and vanished like sparks in a storm. It was tragic, but inevitable. Stars died. Planets shifted. Ecosystems collapsed. Intelligent life, no matter how advanced, eventually faced a challenge it could not overcome. Humanity, it seemed, had finally reached that point. For centuries, Earth had been unraveling. Endless resource wars poisoned the atmosphere. Weaponized nanotech devoured entire coastlines before being contained at terrible cost. Climate collapse triggered superstorms capable of reshaping continents. Then came the embargo, when neighboring species, fearing human expansionist tendencies, restricted access to off-world materials critical for planetary stabilization. Humanity had survived catastrophe after catastrophe. But survival had limits. By the time the Council issued Protocol 77, Earth's oceans had become acidic wastelands choked with metallic residue. The Amazon rainforest existed only as a mapped memory in historical databases. Cities once home to billions stood silent beneath toxic orange skies. Satellite observations suggested fewer than 10 million humans remained alive on the surface. Most species would have evacuated long before reaching this stage. The galaxy offered relocation programs, preservation habitats, even genetic archives to ensure cultural continuity. Humans declined them all. Refuge vessels arrived in orbit, transmitting coordinates to safe colony worlds. Automated translators broadcast welcome messages in every known Earth language. No one boarded. Instead, the ships received a response so brief it was initially flagged as transmission error. Earth is not dead. Not yet. Council observers classified the statement as denial psychology, a predictable emotional reaction to impending extinction. Historical records showed similar behavior in at least 17 other species before their disappearance. Still, the humans' refusal created a logistical problem. Without voluntary evacuation, preservation of human knowledge would require forced extraction, an action the Council preferred to avoid unless absolutely necessary. So they waited and watched. From orbit, Earth looked worse each passing decade. Storm systems expanded until entire hemispheres disappeared beneath swirling clouds of chemical ash. Lightning storms raged constantly across continents where forests once stabilized atmospheric balance. Glacial melt had long since destabilized ocean currents, creating heat patterns that turned once temperate zones into furnace landscapes. Cities crumbled into skeletal outlines barely visible beneath layers of dust. Signs of organized civilization faded. Human population estimates dropped below 5 million, then below 1 million. Then something unexpected happened. Energy readings began appearing in locations previously classified as uninhabitable. Deep beneath collapsed megacities, power signatures flickered to life. Seismic scanners detected rhythmic vibrations inconsistent with natural tectonic movement. At first, analysts suspected automated defense systems activating in response to environmental instability. But the signals grew stronger, coordinated, intentional. Massive sections of ruined infrastructure shifted as ancient mechanisms, some dormant for centuries, powered up simultaneously. Orbital telescopes captured brief glimpses of enormous metallic structures unfolding beneath layers of rubble. Entire city blocks sank slowly into the ground, guided by colossal support mechanisms buried long before the Council had even begun monitoring Earth. Hidden vault networks activated across multiple continents at once. Humans had prepared for this moment. Seed Preservation Archives released atmospheric drones carrying engineered microorganisms designed to break down toxic compounds. Underground fusion cores, protected from surface disasters, began supplying energy to subterranean habitats large enough to house millions. Even more surprising was the scale of coordination. Human transmissions, once chaotic and fragmented, now moved with unified precision. Thousands of isolated survivor groups synchronized actions across the globe without central leadership visible to external observers. They had not simply survived the collapse. They had planned for it. Council analysts began reviewing archived human cultural data to understand the pattern. Again and again, historical records showed the same tendency. Humans investing resources into worst-case scenarios others considered unnecessary. Cold War bunkers. Seed vaults beneath Arctic ice. Digital knowledge repositories stored on lunar servers. They had always assumed disaster would come eventually. And now that it had, they were ready. But readiness did not guarantee survival. Earth's atmosphere remained lethal to unprotected biology. Surface temperatures fluctuated unpredictably between freezing storms and extreme heat waves capable of melting structural alloys. Statistically, long-term survival remained impossible. Yet population decline stopped. Then slowly reversed. Within 20 years of Protocol 77 activation, human numbers began increasing. Small at first, then steadily. Council simulations failed repeatedly when attempting to model the recovery. Every projection ended in extinction. Every observation contradicted it. Then, without warning, human surface transmissions ceased completely. No distress signals. No final messages. Just silence. For 12 standard years, Earth emitted no detectable communication from its surface. Council observers prepared to archive the species as extinct. Then deep scan sensors detected something unprecedented. Human signals had not vanished. They had moved. Far below the planet's crust, deeper than any species had ever attempted permanent habitation, vast networks of artificial structures pulsed with coordinated activity. Humanity had not fled their dying world. They had gone underground. And they were still building. The first deep scan image of the underground networks was dismissed as sensor distortion. No civilization willingly built cities that far beneath a planet's crust. The engineering challenges alone bordered on impossible. Pressure increased exponentially with depth. Temperatures rose beyond the tolerance range of most structural alloys. Even with advanced technology, maintaining stable habitats in such an environment would consume more resources than abandoning the planet entirely. Yet repeated scans confirmed the same result. Human civilization had moved downward. Layer after layer of vast artificial caverns stretched beneath Earth's ruined continents. Entire regions of the mantle had been hollowed with geometric precision, reinforced with materials unfamiliar to Council databases. The structures formed a lattice of immense support columns and adaptive frameworks designed to absorb tectonic stress rather than resist it. Humans had not merely built shelters. They had engineered a second world inside the first. At depths previously believed uninhabitable, artificial gravity stabilizers counteracted seismic movement. Magnetic field generators redirected geothermal energy flows, transforming destructive heat into usable power. Gigantic atmospheric processors converted trapped gases into breathable air mixtures carefully calibrated for long-term habitation. The deeper Council probes scanned, the more impossible the discovery became. Human cities extended downward for kilometers, connected by transit systems operating through vacuum-sealed tunnels that minimized energy expenditure. Entire ecosystems existed beneath artificial suns, bioengineered light sources replicating the spectral balance of Earth's long-lost surface daylight. Forests grew beneath stone ceilings. Rivers flowed through channels carved directly into bedrock. Even oceans had been recreated, smaller in scale, but fully functional ecosystems sustained through molecular filtration systems capable of removing contaminants atom by atom. Humanity had not simply survived environmental collapse. They had replaced the environment. Council scientists struggled to classify the achievement. Terraforming typically required altering planetary atmospheres over centuries. Humans had bypassed the process entirely by reshaping the planet internally. Instead of adapting the world to life, they adapted life to the world they could build. Population estimates rose steadily as new habitation zones came online. Birth rates stabilized. Genetic diversity remained intact thanks to preserved archives of human DNA stored in vault systems predating the Extinction Declaration. Yet biological adaptation had also begun altering the species itself. Long-term exposure to high-pressure environments accelerated subtle physiological changes. Human skeletal structures grew denser. Cardiovascular systems evolved improved oxygen efficiency. Enhanced cellular repair mechanisms reduced damage caused by radiation exposure leaking through unstable crust layers. Some modifications were natural evolution. Others were intentional. Council surveillance intercepted fragments of scientific transmissions referencing controlled gene therapy programs designed to increase resistance to toxins, heat fluctuations, and atmospheric instability. Humans were redesigning themselves for survival conditions most species would consider intolerable. When Council envoys attempted diplomatic contact, they expected desperation. Instead, they encountered calm determination. A human representative transmitted a message from one of the subterranean habitats, appearing on screen against the backdrop of an artificial forest illuminated by a contained fusion sun. "You misunderstand our situation," she said. "You believe we are trying to restore what was lost." Behind her, engineered trees filtered atmospheric carbon compounds, while microscopic drones pollinated flowers designed to produce nutrient-rich fruit capable of growing in controlled soil matrices. "We are building something new." Council analysts requested clarification regarding long-term planetary recovery plans. The response was unexpected. "Surface restoration remains a priority," the ambassador explained. "But survival does not require immediate reclamation." She gestured toward the cavern skyline where layered habitats stretched into the distance like illuminated constellations trapped inside stone. "We are no longer dependent on a stable biosphere." The implication unsettled Council strategists. Every known species relied on delicate environmental balance for survival. Ecological collapse typically triggered irreversible decline. Civilizations that lost their homeworld rarely regained comparable stability elsewhere. Humans appeared to have eliminated that vulnerability. By creating self-contained ecosystems independent of planetary conditions, they had broken a fundamental limitation of biological life. Extinction events typically targeted environmental stability. Humans had removed environment as a requirement. Further analysis revealed expansion beyond Earth itself. Autonomous mining operations extracted resources from nearby asteroid fields, supplying raw materials for continued construction. Experimental propulsion systems launched deep space vessels designed for long-duration missions in hazardous regions other species avoided entirely. Radiation-heavy sectors near pulsars. Gravitationally unstable zones surrounding collapsed stars. Regions previously considered scientifically valuable but operationally impossible. Human exploration logs described these locations not as dangers, but as opportunities to test survival adaptations. Council behavioral specialists revised psychological assessments of the species. Humans did not perceive hostile conditions as barriers. They perceived them as variables. One strategist summarized the emerging consensus in a restricted report. A species that evolves specifically in response to extinction pressure will not behave predictably during existential conflict. The conclusion raised troubling possibilities. If extinction strengthened humans rather than eliminating them, traditional deterrence models would fail. Threats designed to discourage aggression could instead accelerate their development. The report ended with a statement previously considered theoretical. Humanity may represent the first recorded example of a civilization capable of transforming extinction-level events into evolutionary catalysts. Meanwhile, deep beneath Earth's fractured crust, construction continued. Layer by layer, generation by generation. The planet above remained scarred and toxic. Storms still raged across continents. Oceans remained unstable. But beneath the devastation, a new civilization was taking shape. Not one dependent on fragile ecosystems or predictable climates, but one designed to endure anything. Earth, long declared dead, had become something else entirely. Not a graveyard of a species, but the foundation of one that refused to disappear. The deeper humanity built, the more the galaxy realized something fundamental had changed. Most civilizations developed technology to protect themselves from danger. Humans developed danger to improve their technology. The underground cities of Earth had begun as emergency shelters, but over generations they evolved into laboratories of survival. Every limitation imposed by the dying planet became a problem to solve, a variable to optimize, a weakness to remove. Harsh conditions no longer threatened human civilization. They refined it. Artificial ecosystems beneath the crust were no longer crude imitations of surface life. They had surpassed the originals. Engineered forests recycled air more efficiently than any natural biosphere. Root systems formed organic filtration networks capable of neutralizing toxins in minutes rather than centuries. Microbial colonies designed through adaptive gene sequencing repaired soil degradation automatically, responding to environmental imbalance faster than any naturally evolved organism. Human scientists referred to the process as directed resilience. Instead of waiting for evolution to slowly produce favorable traits, humanity guided change deliberately. DNA became both historical record and editable blueprint. Generations born beneath Earth's surface adapted to conditions their ancestors could not have endured. Their lungs processed lower oxygen concentrations with minimal efficiency loss. Their eyes adjusted more rapidly between light spectrums produced by artificial suns. Neural implants enhanced pattern recognition, allowing individuals to interpret complex environmental data intuitively. Biology and technology were no longer separate disciplines. They were integrated survival systems. Yet humans did not limit their adaptation to underground environments. They prepared for extremes beyond their homeworld. Exploration vessels launched toward the most hazardous regions of nearby space, carrying crews genetically and technologically modified to endure environments previously considered unsurvivable. Near neutron stars, where radiation levels disrupted most electronic systems, Human ships deployed adaptive shielding grown from self-repairing materials capable of restructuring molecular bonds under stress. Close to unstable stars, research teams studied solar eruptions not as threats but as energy sources. Within decades, humanity had expanded into territories the rest of the galaxy observed only through distant probes. The shift in human strategy confused Council observers. Most species avoided high-risk exploration zones because the cost of failure outweighed potential scientific gain. Civilizations depended on stability. Predictability allowed long-term planning. Preservation of population remained the highest priority. Human doctrine appeared inverted. Risk was not avoided. Risk was cultivated. When a human research vessel was lost studying gravitational distortions near a black hole, the mission logs revealed no expressions of regret, only extensive data transmissions recorded until the final microsecond before destruction. Within 2 years, improved vessels returned to the same region with structural modifications derived from the failure analysis. Each loss became instruction. Each disaster became design improvement. Human archives catalogued extinction-level threats with meticulous detail. Solar flares, atmospheric collapse, pandemics, resource scarcity, technological malfunction. Every scenario was modeled, simulated, and tested repeatedly. The goal was no longer simply survival. It was inevitability. Council military analysts began revising strategic projections involving potential conflict with humanity. Traditional combat simulations relied on predictable responses to threat escalation. Species typically withdrew when casualties exceeded acceptable thresholds. Humans did not possess comparable thresholds. Casualty reports were integrated into strategic learning algorithms. Autonomous combat drones evolved their tactics in real time using battlefield data gathered seconds earlier. Armor systems grown through bioengineered lattice structures adapted to energy impacts by redistributing molecular density across impact zones. Human warships appeared to grow stronger during extended engagements. Weapons previously classified as experimental or unstable became standard deployment systems for human fleets. Controlled singularity projectors, variable frequency particle lances, and adaptive kinetic fields capable of altering density mid-flight entered operational service decades earlier than Council projections considered feasible. Human engineering tolerated failure rates other civilizations deemed unacceptable, because failure accelerated improvement. One Council strategist summarized the developing concern in a confidential briefing. A species that improves through catastrophe cannot be contained using conventional deterrence models. The implications extended beyond military considerations. Human cultural philosophy had shifted alongside technological evolution. Historical human literature once described extinction as tragedy. Modern human education described extinction as a design challenge. Children born in subterranean habitats studied environmental collapse scenarios as foundational curriculum. Students simulated ecosystem failures and proposed adaptive countermeasures as routine academic exercises. Psychological resilience training began in early developmental stages, conditioning individuals to interpret crisis as opportunity rather than loss. Language itself evolved. The word impossible gradually disappeared from common use. In its place emerged a more precise classification. Not yet solved. As humanity expanded outward from their rebuilt world, Council observers noted a disturbing pattern. Human exploratory missions did not seek the safest paths through the galaxy. They mapped the most dangerous ones first. Regions of unstable spacetime. Planets with volatile atmospheres. Star systems prone to catastrophic radiation bursts. Humans catalogued them carefully. prepared for them deliberately, improved because of them consistently. One archived human research thesis summarized the species' guiding principle in a statement later circulated among council strategists. Extinction pressure is simply evolution accelerated. The galaxy had encountered resilient species before. They had encountered intelligent species before. They had even encountered aggressive species before. But never one that treated existential threat as developmental stimulus. Human civilization no longer feared extinction. They trained for it. And in doing so, they became something entirely new. A species no longer defined by the environment that created it, but by its ability to survive environments no life was meant to endure. The signal did not resemble language. It did not resemble communication at all. Across the Orion Arm, observatories detected a pattern of energy fluctuations so precise that natural explanation became statistically impossible. Entire star systems experienced simultaneous electromagnetic disruption lasting exactly 3.2 seconds, repeating at mathematically perfect intervals. At first, scientists believed it was a cosmic anomaly, a previously unknown stellar interaction. Then the first colony vanished. No distress call. No debris. No radiation spike indicating planetary destruction. Just silence where billions of lives had existed hours before. Within days, more systems fell dark. Automated probes sent to investigate transmitted fragmented sensor logs before failing. The recordings showed fleets of geometric constructs moving without visible propulsion, their surfaces absorbing electromagnetic radiation instead of reflecting it. Conventional detection systems struggled to track them, as if the objects existed partially outside measurable space. Ancient archival databases eventually provided identification. Designation: Autonomous Purity Directive. Origin: unknown precursor civilization, extinct approximately 3 million years prior. Primary function: eliminate emerging intelligent species before technological maturity reached unpredictable thresholds. In simpler terms, the machines existed to prevent civilizations from becoming threats. For millions of years, the directive had remained dormant. Until now. Council defense forces mobilized immediately. The most advanced fleets in the galaxy converged on the affected regions, deploying containment strategies refined through centuries of interstellar conflict. None of them worked. The directive did not behave like any known enemy. Their constructs adapted to weapon frequency patterns within seconds. Shield harmonics that defeated them in one engagement became ineffective in the next. Communication interference prevented coordinated counterattacks, isolating fleets before systematically dismantling them. Entire armadas disappeared without visible signs of battle. Species that had endured for tens of thousands of years fell within weeks. Evacuation corridors filled with refugee vessels fleeing toward safer sectors. Human territory lay directly in the projected expansion path of the directive. Council strategists prepared emergency relocation orders, assuming humanity would retreat as others had. Instead, human fleets advanced toward the threat. Their first contact engagement was brief and catastrophic. 37 human warships entered a contested system previously defended by 3 allied civilizations. Sensor recordings showed the directive's constructs disassembling vessels with microscopic precision, dismantling structural bonds faster than automated repair systems could respond. All 37 ships were destroyed. But human transmissions continued until the final microsecond. Every sensor reading, every structural stress fluctuation, every energy signature variation. The loss had been intentional. Human analysts extracted the data and transmitted revised combat algorithms to the remainder of their fleet. The next engagement lasted 12 seconds longer. Human vessels modified their defensive geometry mid-combat, altering structural alignment to reduce vulnerability to molecular disruption fields. Experimental energy dispersal systems redistributed incoming attacks across rotating armor lattices grown from adaptive metamaterials. Losses remained severe, but the directive did not achieve immediate victory. Each battle followed a similar pattern. Human fleets entered combat with incomplete understanding of the enemy. They left with more. Some ships deployed unstable energy cores designed to overload directive shielding frequencies, sacrificing themselves to create temporary windows of vulnerability. Others transmitted real-time combat telemetry to distant analysis networks that updated tactical protocols faster than directive adaptation cycles could compensate. Human strategy prioritized learning speed over survival probability. Every destroyed vessel accelerated improvement. Autonomous drone swarms developed self-modifying behavioral patterns, altering movement unpredictably enough to delay directive targeting calculations. Bioengineered computational substrates processed battlefield data using hybrid organic logic systems resistant to electromagnetic interference. Within months, engagement duration increased dramatically. Human ships still fell, but fewer with each encounter. The directive had never faced an opponent that treated destruction as feedback. Other species sought decisive victories. Humans sought continuous refinement. Eventually, the balance shifted. In the Trappist expanse, a human task force deployed synchronized gravitational shear weapons calibrated using data collected from previous losses. Directive constructs, optimized for conventional spatial geometry, experienced structural instability when exposed to localized distortions in spacetime curvature. For the first time, directive units were destroyed faster than they could adapt. Human fleets pressed the advantage. Instead of consolidating territory, they pursued directive forces into regions of increasingly hazardous astrophysical conditions, radiation-dense nebulae, magnetically unstable star clusters, and regions saturated with charged particle storms capable of disabling most electronic systems. Human vessels operated effectively in environments considered operationally impossible. The directive's adaptation models did not account for combatants intentionally selecting battlefields lethal to themselves. Human commanders transmitted a message intercepted by multiple Council monitoring stations. Extinction environments are our training grounds. The final engagement occurred near the remnants of a collapsed binary star system, where gravitational turbulence distorted sensor accuracy and destabilized conventional propulsion systems. Human fleets entered the region deliberately. Directive constructs followed. Adaptive armor systems compensated for extreme radiation flux. Self-repairing hull matrices regenerated structural damage faster than environmental stress could accumulate. Autonomous targeting networks adjusted firing solutions continuously to account for spacetime curvature anomalies. For 72 hours, the battle continued. Directive forces, unable to predict continuously evolving human strategies, began experiencing cascade failures in adaptive learning models overwhelmed by rapid environmental variation. One by one, the constructs ceased functioning. Then the signal stopped. Across the Orion Arm, energy fluctuations ceased entirely. The Autonomous Purity Directive, active for millions of years, had been neutralized. Council observers struggled to interpret the outcome. Most civilizations survived by avoiding extinction-level conflict. Humanity survived by mastering it. For the first time, extinction had not threatened humanity. Humanity had threatened extinction itself. The war's end did not arrive with celebration. No triumphant broadcasts echoed across the Orion Arm. No victory monuments were constructed in orbit around liberated worlds. Human fleets did not parade their success through Allied territories. Instead, they returned home, back to the scarred planet once declared unsalvageable, back to the world the galaxy had already pronounced dead. Council observers expected to find Earth unchanged, a wounded sphere still dependent on subterranean survival systems. What they discovered challenged every model of planetary recovery ever recorded. From orbit, the first visible difference was color. Where toxic storms once choked the atmosphere, bands of blue began reappearing across the surface. Artificial climate stabilizers, operating for generations beneath the crust, had gradually rebalanced atmospheric chemistry. Nanoscopic environmental processors, released decades earlier, had replicated faster than predicted, breaking down contaminants molecule by molecule. The oceans were returning, not identical to their ancient state, but alive. Engineered microorganisms reconstructed plankton populations capable of surviving variable temperatures and chemical instability. Coral analogues grown through bioadaptive fabrication formed reef structures resistant to acidification. Entire marine ecosystems had been designed with resilience as a primary function. Forests followed. Seeds preserved in vaults older than the Extinction Declaration were not merely replanted, they were improved. Root networks communicated through bioelectrical signaling pathways, allowing entire ecosystems to respond collectively to environmental stress. Fungal systems redistributed nutrients dynamically, ensuring no region collapsed due to localized scarcity. Storm patterns stabilized. Continents cooled. For the first time in centuries, rain fell on Earth without carrying corrosive compounds. Humanity had not restored the planet. They had redesigned it. The surface world became a living demonstration of survival principles learned during centuries of adversity. Every ecosystem incorporated redundancy. Every environmental process included adaptive safeguards. Every biological system possessed the capacity to evolve deliberately if conditions changed again. Extinction was no longer a singular threat. It was a continuously monitored variable. Council envoys visiting Earth reported a cultural transformation equally profound. Human architecture combined organic and technological structures seamlessly. Buildings grew rather than being assembled. Infrastructure adapted in real time to population movement patterns. Energy networks adjusted automatically to fluctuations in resource availability. Children played beneath open skies their ancestors had believed they would never see again. Education systems reflected the species' transformation. Historical records of planetary collapse were not hidden or softened. They were studied, analyzed, understood. Students learned how ecosystems fail before learning how they function. They studied psychological responses to crisis alongside mathematics and engineering. Resilience was no longer an abstract virtue. It was a technical discipline. Human historians began documenting a new timeline, not based on political eras or technological milestones, but extinction events survived. The collapse era, the atmospheric failure period, the resource conflict century, the directive war. Each event recorded not as tragedy, but as iteration, as improvement, as proof that survival could be engineered. The Galactic Preservation Council convened an emergency session to reclassify humanity's species designation. Existing categories could not adequately describe a civilization that treated existential threats as developmental catalysts. Biological species relied on environmental stability. Technological civilizations relied on infrastructure continuity. Aggressive empires relied on strategic dominance. Humanity relied on persistence. A new classification was proposed. Type X. Extinction-resistant intelligence. Criteria included demonstrated capacity to survive multiple independent extinction-level events without loss of civilizational continuity, ability to adapt biological and technological systems simultaneously, and cultural reinforcement of resilience as a foundational principle. Only one species met the requirements. During the official designation ceremony, a human ambassador addressed the Council. She appeared unremarkable by traditional standards. No visible augmentations marked her as genetically modified. No technological implants were externally apparent. Her species no longer required visible distinction between natural and engineered traits. Resilience had become intrinsic. "You called us endangered," she began calmly. "You calculated our extinction probability with extraordinary precision." Council representatives remained silent. "You were correct," she continued. "By every known model, we should not exist." She paused, allowing the weight of the statement to settle across the chamber. But extinction is only inevitable if a species stops adapting. Archival records later showed that her closing statement became required reading in multiple council academies. Survival is not luck. Survival is design. When asked privately how many extinction-level crises humanity had endured since the first atmospheric collapse, the ambassador reportedly smiled before answering. "We stopped counting after the first 1,000 years. Earth, once classified as a planetary failure, became a research destination for civilizations seeking to understand adaptive resilience. Delegations arrived from species whose homeworlds faced instability, requesting access to human environmental reconstruction methods. Humans shared freely, not out of altruism alone, but from cultural philosophy. Every species that survived strengthened the galaxy. Every extinction prevented increased collective resilience. Human archives preserved a simple principle repeated across centuries of hardship. Existence is not guaranteed, but persistence can be learned. As exploration vessels departed Earth once more, this time not in desperation but in curiosity, Council observers revised long-term projections for humanity's future. Previous models predicted eventual decline consistent with all known civilizations. Updated models contained too many variables to calculate reliably. For the first time, the probability of human extinction could not be determined, not because the threat no longer existed, but because humanity no longer behaved like a species capable of disappearing. They had faced annihilation. They had adapted. And now, the galaxy understood a truth once considered impossible. Some species do not survive extinction. Some species evolve beyond it.